Dr. Prakhyat.
Thank you. So good afternoon, everyone. I am Dr. Prakhyat Roop. I'll be talking about the edgeless phase matching technology to achieve complete panfocality. And I do receive trial grants from Care Group for doing this trial. So when we talk about extended depth of focus lenses or presbyopia correcting lenses, what we are looking for is least side effects, a good range of spectacle independence, and no compromise in quality of distance vision. Now, when we look at the extended depth of focus lenses, the quality of vision concerns are by far the least in this category of lenses, which is why it is more or less the popular choice nowadays when we want to choose a hassle-free IOL. But it does limit our range of vision. So what does work for the extended depth of focus lenses, if we look, is that it utilizes the complete optic surface to focus light on some useful focus. An elongated focus meaning no significant drop in light energy across the focal range. And that reduces the perception of halo because there is a continuous source of light. And that is why the perception of rings which are illuminated and then dark and then illuminated is gone. And that is why the patients feel better adapted to it. So in an extended depth of focus lenses, the surface is always working to push light to a good, useful focus. Now compare it to a diffractive lens, where the stray light goes haywire at different vertical edges of the diffractive IOLs, and that leads to starbursts, side effects, scattering, waxy vision, and all sorts of night driving problems. And that is why we want to go the EDOF way. But EDOFs are limited in their performance because after an addition of about 1.25 diopters, there is a perceptible drop in the quality of vision and contrast. And that is why there cannot be an EDOF that gives us, by changing the spherical aberration, a full range of vision. The edgeless phase matching technology bridges that gap for us. It comes with the EDOF advantage and a full range of vision. So basically, it utilizes the complete surface of the optical element, not wasting any part of the incident light into the noise, into the scatter. And that is why we achieve a full range of vision along with minimum side effects. This is the first picture of the prototype that was made by Care Group, and it has absolutely 0 steps. This is our clinical study outcomes, which is under publication currently, so we'll discuss them briefly here. If you look, the reflex on the slit lamp, you see a clear optic. There is no rings, there is no backscatter of the light, so you can see that the lens has a completely smooth surface, so to say. And we've analyzed the first 500 eyes, and we've got unaided distance vision, binocular unaided distance vision of 20/20, intermediate of 20/20, and near vision equivalent to 20/25, which is about N5. In India, it is finer, 1 point finer than the newspaper print. So if we look at the monoocular mean visual acuity just to see the performance of the IOL, we see that it performs at all distances a mean better than 6 by 7.5 or 20/25. And if we look at the presbyopia range, then closer to 75 centimeters, you see that there is a tendency towards reaching 6 by 7.5, that is 20/25. So always better than N6. If we talk about the disturbing side effects, the starbursts, waxy vision, photic phenomena, those adverse visual symptoms that make the patients not want a full range of vision lens are completely gone. They're experienced by less than 0.01%, that is 3 patients in this whole study. But halos is something that is appreciated by about 4.8% patients. And a peculiar feature with the halos in this lens is that they appreciate it at very distant light sources. And as the light source comes closer, for example, a car is driving at the night, as it approaches you, the halos are gone. So it's more in the smaller light sources that are at a far distance, and that is why night driving comfort is excellent. We also had a subgroup in this cohort where we had implanted another trifocal lens and the patients were not satisfied with the quality of vision, and we chose to implant in the other eye. When the patient underwent the surgery for the other eye, we implanted the Naturo panfocal IOL. And we found that the primary reason for dissatisfaction was severe starbursts, and none of the patients in the Naturo panfocal IOL found this problem. And that is where, in the initial part of the trial, my confidence with using this lens in various combinations actually started to build up. This is pretty much the design of the lens, where you have a negative kinoform phase matching. Now this is, to simplify it, this is the base curve of the lens. If you combine it with a conventional kinoform profile, what you will get is a bifocal diffractive IOL. If you were to combine this base curve with a negative kinoform profile, you would get something like a 20 diopter with a minus power at the second focus. So you would have, say, something like 20 and minus 2 instead of 20 and plus 2. So what ingeniously the R&D team at Care Group did is, to simplify it, they combined these profiles to get a continuous surface that sends light to useful foci only. This is not entirely a diffractive technology. It is definitely not a refractive technology, and that is seen when we do the simulations and the research behind it. It shows us that the light is actually not following either of the two optical phenomena. So it's essentially a new way of optics. If we compare it to the leading trifocals in our practice, then we see that this wasteful energy that was earlier getting wasted and causing us the side effects is now actually getting utilized, and we see that in the increase of MTF at the various desired focal lengths. In my practice, just for my own knowledge, I did a high resolution aberrometry for analyzing the in vivo IOL performance of these different lenses, and I'm just going to summarize the results for us. So if we compare the range of vision, it provides a complete range of vision from distance to near, making your patient spectacle independent. And it has a stress ratio which is extremely good compared to any other EDOF or presbyopia correcting lenses that we've been using in our practice. We've found that we get an excellent quality and an excellent range of vision, by far better than any other, and quite comparable in terms of its contrast to the monofocals. So at the last, I would like to congratulate this group for innovating and bringing us newer technologies continuously for the past several years. Thank you.
Thank you, Dr. Roop, for your presentation. I would like to ask you a question about the lens. Is it hydrophobic or hydrophilic?
So it is a hydrophobic material and it is cast molded. So in fact, you'll be surprised to know Care Group is the only manufacturer of cast molded IOLs in the world that does not have a problem of glistening.
Thank you. Now we are moving to any person? Yes.
This one, sorry. So this, how do you think? This lens is Adolf lens or diffractive lens? How do you think?
So,
It's not like a both, right?
sorry,
So this is a, how do you think that this is a little bit the curvature they have? You said a very small, this is a diffractive lens, you call it?
So that's what I was showing, that there was a study that in their R&D stage, this was my question to them as well. So in their R&D stage, they found that the light is actually it's not a refractive lens, but it's also not exactly following the conventional diffractive light distribution, or so to say the phase matching in the diffractive lenses that we have, like the conventional trifocals that we are using, that we are used to seeing. So they had to devise new mathematical equations to actually bring about the correct light distribution and phase matching in this lens. So it's essentially, that's why they've brought it out, and it's their proprietary edgeless phase matching technology, basically.
Thank you.